everyone. As Jonathan said, I'm a lead machine learning engineer. I have more than 7 years of experience in this field. What to know about me? I love cooking, food, but also software with machine learning flavor. So this is exactly what to know about me. Recently, I became an MLflow ambassador. So for people who doesn't know what MLflow is, an open source framework that handles the life cycle of machine learning models. And we will see exactly how we use it to scale our machine learning platform. So let's start about our product. So in Vedrai, we have different products that support our clients to take data-driven decisions. How to do that? So the first layer that we have is the connectors. So we connect the databases from our clients, but also from external variables data. And we pass all this information or data to the build part, where we map all the decision process map. So what that means, we just build a graph, mathematical graph, that can simulate the process of taking decision, the business model of that client. The client can define exactly what KPI want to optimize, for example, the revenue. I want to optimize my revenue. And then we pass all this information to the simulator part, where we create the predictions data. So we create forecasting. With forecasting models, we create predictions, we create also simulations, and so on. And at the end, we have the layer of explain, where we try to exactly optimize the decisions of our clients, to explain to them exactly what steps to take and what are the risks present for their scenarios. We would like also, from September, to build the highlight layer, where we want to add generative AI algorithms to explain exactly the plots, to explain exactly the actions and decisions to our clients, because they are not that technical to understand what is heat map plot, for example. And we would like also to build a chat bot that can interact all the time with different clients that we have, because the platform is multi-clients. So there is also the technical departments of our clients that are different users, from the financial department, from the CEO, and that's on. So they have different backgrounds of our clients that work all together in the same platform, and they need different interactions. So let's try to talk about the important slide. The slides before, my manager asked me to do, so this is exactly. Let's have some fun with the real problems that we had. The interesting part of the simulator is the forecasting. So we had lots of challenges to build the machine learning models. We have two types of data. So we have the external data that comes from our data providers, and we have the internal data that's come from the connectors of our clients. And we need exactly in the first step to check the data quality, check if people within our company have the right access. We need to check also the metadata, the types of the columns. We need to also check the description of each column, what that means. We need to know exactly the lineage part and build all these ETLs. And then we need to be sure that these ETLs scale and don't have some problems. So this is the first challenge that we had. The second one, once the data are prepared and ready for use, we build a lot of machine learning models that try to create future data. So we need to be sure that we have the best model. So we need to tune all the different models, different CPR parameters, and need to be sure that all this platform is scaling. And we need to register the best model and need exactly to know what strategy to do to deploy it in production. Once in production, we need also to scale that the inference part is working very, very well. So this is the different challenges that we have during the life cycle of building machine learning models. This is the equivalent technologies that we used in each step. So for the first step, we used, for the ETL, we used Databricks with PySpark and different clusters and workflows from Databricks. In the part of model building, we used serverless architecture that I will explain after this slide, in the next slide, with different open source machine learning models. especially from a library that's named Darts. We have also used other libraries like Gluon, and we're trying to use Nextla in the next steps. And at the end, we used Databricks as an infrastructure for the inference part. All in this life cycle, we used MLflow and Delta Lake all the time. So for the infrastructure that we built for the training part is built in AWS, and is 100% serverless. So we used only the services that they are serverless. We have an event that can be scheduled, or it can be on demand to run some kind of variables from the clients. For example, the clients say, OK, I will to know exactly how is going my sales. So there is like the variable sales forecasting that trigger this infrastructure. The events starts a workflow in AWS step function that orchestrates all the training parts. The first step in that step function is the Lambda, is the first Lambda, is kind of dispatcher that take the sales forecasting or the sales variable and try to build all the different models that need to be built. For example, if the client is a retailer, so we need to go store by store, city by city, and build all different time series, and then we orchestrate all the jobs for the machine learning part. Once we have all the configurations, we distribute them in another mapping step using AWS Batch with Fargate, where we run all the machine learning and forecasting models. Each model each job tries to find the best model and track all the metrics, track all the parameters, all the artifacts of that model in MLflow server. The MLflow server is handled by Databricks, so we don't need to handle that part. And once all the models are, all the jobs achieved the results, there is like a last step where we take each model and try to find exactly which strategy that we need to use for put it in production. So they have different strategies, and we will see that in the notebook after. And then we notify the triggers about the results. For the inference part, we have different types of inference. So the basic case is the batch inference. For example, for external variable, the variables are scheduled for each month, for each week, for each day. So we know exactly when we need to do inference. The data are already built, so we don't need to wait for the ETL part. We have a large volume of data to predict, and there is kind of cold start at the end to run the clusters. And this is a perfect case for the external variables where there is no need to wait for predictions. So there is just a job, a workflow, that take data that's already built and then make predictions using the MLflows or by pulling models from MLflow server. The second case of inference is, for example, we can use it for what-if scenario. So when clients, for example, say, OK, what will happen if I put 20% of discount? So we need to rerun the predictions. And we can use, for example, the real-time inference. It's an endpoint that is provided by Databricks that invoke directly the model that is already registered there. And this is a perfect case when you have like a small payload because we're using API. And it has some limits. For example, with Databricks, we have like 3,000 queries per second as a limit. And for some cases, when the clients run a lot of simulations, they are not running one scenario, but they are running, I don't know, 1 million of simulations. This part reached the limits, and we need to see exactly how we can fix that. So at the beginning, we tried to create kind of token bucket infrastructure, if I can say, because it's a little bit complicated. In the slides, we cannot see the complications, where we try to define a bucket as a capacity of the API load balancer. And we try to see exactly for each token, we try to put it first in the in that bucket and see if the bucket has the right capacity. If the capacity is enough, we can move forward. This resolves the problems, but make the simulation parts very, very, very slowly. So our managers try, okay, good, it works, but it's very late, so try to find another solutions. And the last solutions is in the case of we have a lot of data to run, is the streaming part. So the streaming part from our clients and from our inference part, we put Kafka. In this case, we put AWS MCK. Is a self-managed Kafka from Amazon, so we don't handle the server, but we pay all the time for that, so it's not serverless. And in that part, we put all the topics. The topics are all the payloads that come from the clients, and Kafka and the inference part receive all these messages and play the inference part and rewrite it in different other topics that the consumer use for the inference. This part help us to go very slowly, very quickly, I'm sorry. And the only thing about this is that we need to pay all the time about Kafka because it's not serverless. And it's something that we didn't I don't know, it's something that in the first we tried to build 100% serverless infrastructure, but with the use of Kafka, it makes the things very complicated. So for this, we move in a kind of different solution that we can use based on the use case that we have in the initial, the requirements that have in the initial part. So this is a matrix that can give us conclusion about which use case, which infrastructure to use based on the requirements that we have in the initial. And that's it for the slides. So let's see exactly how all that works. So I prepared a notebook here that we can see exactly how to use MLflow in all these parts and how we can use the inference part. So the requirements to use these notebooks are having Databricks or a notebook. We can use also MLflow self-managed server for the open source part. There is also other two packages that they are private that I already installed in this notebook for running the training part and kind of algorithms that we built to make the flavor of models more custom. And the first thing to do is to check exactly if the catalog of my clients is already built, or if in the opposite case we need to build it, to create it. Once the catalog is okay, the permissions, the security part is checked, I need only to define the horizon, to define the granularity of data, to define different parameters, and define the catalog where data are already present and already checked for the quality. And then we load this time series. So this is an example of a time series. Once I have this, I define different models that I want to run. For example, we have Prophet, we have Arima, we have other different models. In this notebook, I just used the simple ones that can build very quickly. And I define exactly the format of the model that I want in output, for example. This is very important because all the models that were built will be in a container, for example, Docker, and I need to specify exactly all the libraries and the things that need to be already up there, and to be sure that the model will works as expected. Then here I define some strategies and I define some configurations to see exactly how I want my model will be deployed. And I defined also how I would like to predict my data, because we are not predicting only by median, but we are predicting using the predictive interval. So there is lots of different parts, with different methods of making predictions. And then I just run the code to create the best model. So this is exactly the part of creating the catalog of the model. Here the part of tracking the model during training. So in this part, we are trying to find or to track or to save all the metrics that's coming from the training model, included the metrics from the infrastructure. For example, the execution time, the cost, because the cost can be different, and clients are paying for the cost for the execution that they are using. And we also track the parameters of the model. For example, we can track initial rate, all the parameters of the best model. Once we have the best model, we just registered in MLflow as a candidate. So it's not all the time the best model is the last one, but it can be only one candidate to see exactly if it's ready to put it in production. When it's done, we have something like that. So this is exactly my catalog. Here I can see exactly all the versions that I already ran. And I can see the permissions. For example, I can apply different permissions from some data scientists. For other data scientists, I will apply different permissions. I can also go to each version and know exactly which alias we have. So we have different workspace in Databricks. This one is for development. So when we want to go for production or quality assurance workspaces, we would like to move from different stages. We will not like train the model again, especially for the market, for the external variables. So we just like copy the same model in the other workspace as candidates and try to challenge the models. And this alias can help us to do that and reduce the cost of training. If I want to see exactly all the metrics about this model, I just need to go to the run execution and go to metrics, for example, and see the metrics, or maybe go to parameters to see my parameters in the input. If I want to see the artifact of the model, I just need to go here, and I will have like the pickle model, for example, from here, the requirements to rebuild it, the definition of all the model. For example, here I can see the input schema, and I can see exactly what is the output schema. I can see who is running this model, and all of different configurations. Okay, let's come back to our notebook. Until here, we see exactly how to register a candidate's model. So to see exactly how to put it in production, so we can define different strategies. The basic strategy is to define, for example, in this case, to make it simple, the last model built is the one that will go to production, for example, just to make it easy. And in this case, I just need to try to find the last version that I used and tag it with champion. And I will, in this moment, define the strategy to put that model in production. There is also other strategies that we used. For example, we can do some kind of backtesting in the past and see exactly if the model is stable with time. And if that model is stable, we can put it in production. If not that stable, we can keep the last one. There is also other strategies that we can use, like for A/B testing. We can put them both in production and with different percentage of requests. So we can define 50% of requests will come, we put it, for example, for the last model, and 50% of the other requests we can put it for the old one, and we can challenge them in production. And the model that have more confidence, we can take more volume of requests and maybe can scale to the 100%. So there is lots of strategies, and the most important part here is to know exactly how it's simple to challenge and to find the best model to put in production. once we know exactly which version and we already target to put in production, we need to know exactly in which infrastructure we need to serve that model. There is a lot of choice. We can put it in a Flask server, we can put it in a SageMaker, we can put it in Kubeflow, for example. In our case, we use Databricks serverless inference. And the fact that model is already formatted to run in a container, so we can put it everywhere, so we can deploy it everywhere and do not have any problems. To deploy the model, I just need to make a configuration in that way with the version that I want to deploy and make a post. The post will create an endpoint. So if I go here, I will find my endpoint, and I will find exactly which version is and the percentage of traffic that is that will use this version, and the URL for invocations. And to use the inference part, so in case of real time, I just need to take kind of data, for example, this data, this is raw, to change it to JSON and post it to my invocation URL, and I will have the predictions that I'm looking for. In case of batch, in that case, I need to load the model with the last version or the last with the alias champion, and make predicts, just like call the function predicts, and it will give me the predictions. In case of streaming, I need to write a message in the topic of Kafka, and it's a little bit complicated because I will run other clusters, and it's not something that I can do in Notebook. There is another different Lambda that can do that. And that's all.
Okay, so we have a free question. Okay, so the first one is, how much your models could be customizable in your training pipeline? You can use only PyTorch or also other frameworks for development?
So our models can be there is already there is different flavors of models. There is that will do TensorFlow, PyTorch, Prophet, also with other different flavors. Here we can see exactly the already built flavors. So if there is kind of library that's already handled here, we don't need to rewrite it. In case of a custom function, this is our case also because we have models that we created. In that case, we use PyFunc to redefine the abstract function predicts. So we only need to define what that's me predicts for my model, and that's all. So and in that way, we can make it 100% custom.
Okay, so the next question is, what are the challenges you found putting models in production?
The main challenge that we find is if someone give me this slide 6 months ago, I will pay it I don't know how much just to have it, because the main challenges are not easy to know, but it depends about each use case that we run. For example, when we had like the external variables only, everything is handled by us, so we didn't need exactly to provide something innovative. So we just need to get our data and make predictions, and there is no challenge, important challenges. In case of simulations, when some clients or partners run a lot of simulations, our infrastructure can scale. It reaches some limits, and in that case, we need to figure out some solutions, for example, or using the bucket capacity, but it's not working as well, or the streaming part. So this is exactly the main challenge that we have.
Okay, so next question. During the train, do you track also the data transformation of the data using MLflow? So you can say that a specific model is created from a specific data, etc.
Yeah, exactly. There is also the lineage parts on the model. So we know exactly which data we are using and which version of data, because data also we have, for each data we have different versions. And there is the lineage parts of the model.
Okay, so another one. How do you define the hyperparameter space for each model? Is it customizable?
Yeah, it's from here, from the notebook, from the configurations I put in the beginning. For each model I also put the hyperparameters part. So I put all the interval that I want to run.
Okay, another question. How do you handle the data preprocessing phase in both training and serving steps?
We have different workflows for that. It's not my responsibility. It's more data engineer responsibility. We have 2 types of workflows that we run in Databricks. And for the training, there is also there the lineage, all the data quality parts that check all the parts of preprocessing. For the inference is more about which use case we are using. In case of batch, it's something that do also the data engineer. In case of real-time and streaming, it's something that we do in our case. And there is, with MLflow, this is the signature part where we load the signature of the model and we see exactly which data we need to put and how to build the parts of preprocessing. We would like also in the future to use feature store in case that we will have the features already in some database and we can just need to call it without like running the ETL each time.
Okay, we have another question. What is smart ETL? What's the difference between classical and your ETL pipeline?
Smart ETL, okay, we are talking maybe about this slide. This one. Okay, smart ETL is something that business people call. It's not ETL as other ones, but just our business people try to figure out some sexy names.
Okay, so we have time for another quick question, if anybody wanna ask from the public. So, okay, so we are done. Thank you, Ilyas.